Ella Sorensen has had a long-time interest in shorebirds. Since 1994, she has worked for National Audubon Society, overseeing all aspects of creating the 3,184-acre Audubon Gillmor Sanctuary on the south shore of Great Salt Lake, including land and water acquisitions, restoration planning and implementation, monitoring, education, field trips, and research. The sanctuary focuses on shorebirds in their mudflat and shallow water habitats. She was the Utah Department of Transportation Legacy Nature Preserve Lead from 1999 to 2004. With John Cavitt, Dr. John Cavitt at Weber State, she organized 2 Shorebird Symposiums for wetland managers, agencies, and other interested in learning about shorebirds. She co-authored Utah Birds, Revised Bird Checklist, published in 1985 by the Utah Museum of Natural History with the late Dr. William Behle. Her writing includes the book Seductive Beauty of Great Salt Lake with photographer John George, a monthly bird feature column for 15 years in the Salt Lake Tribune. Her articles have appeared in Birdwatcher's Digest, Audubon Birding, and Winging It, and numerous articles in local magazines and newsletters. She was the lead author of the chapter on Great Salt Lake shorebirds, their habitats and food-based, in the newly published book that we're talking about, Great Salt Lake Biology, A Terminal Lake in a Time of Change. And she currently serves as a member of the Tracy Aviary Science and Conservation Committee and the Great Salt Lake Technical Team.
Every year, a spectacular hemispheric drama plays out all across North and South America. Every year, over 1 million shorebirds congregate on Great Salt Lake. It is one of the largest concentrations of birds on Earth. Many birds occur on shores, and shorebirds do not always occur on the shore. So, what exactly is a shorebird? Great Salt Lake shorebirds are defined as a large, diverse group of birds that include the following: avocets and stilts, large wading birds with long legs and slender bills; plovers, which have short, stout bills and forage visually. They pause, scan, locate, then race in pursuit. Sandpipers, snipes, and their allies are a large and varied group. A few examples among the great diversity of species belonging to this group: marbled godwit, a large wading bird that forages by probing. The majority of the world population stage on Great Salt Lake. Longbill Dowager, a medium chunky shorebird that forages in mud with an up and down motion similar to a sewing machine needle. Peeps. Peeps are multiple small similar looking shorebirds, often missed or lumped together in surveys, but each is a different and unique animal with a distinct range, migration, timing, and ecological requirements. Wilson's phalarope. Wilson's phalaropes are small shorebirds with a unique foraging technique of spinning in water to form a vortex, bringing any available microinvertebrates close by. A large percentage of the world's population of Wilson's phalarope stages on Great Salt Lake. 42 species of shorebirds have been confirmed through our study on Great Salt Lake. 31 of them occur annually, and 19 are common. Of these shorebirds, 9 will stay and nest on Great Salt Lake. Shorebird habitat. Dry and shallowly flooded mudflats are uncontestedly the most important habitat for shorebirds. Good news for Great Salt Lake. There are hundreds of thousands of acres of mudflats on Great Salt Lake, so we really don't have to worry about losing shorebird habitat. And lower levels of water in Great Salt Lake may worry many people, but it is actually good for shorebirds because more mudflats are exposed. These are false statements. Not all mudflats provide the necessary ecological parameters that must be met to make productive shorebird habitat. In fact, at any given time, most mudflats on Great Salt Lake are not suitable habitat for shorebirds, and shorebirds simply do not occur on them. For this chapter, we did not use typical traditional habitat types, which are often not appropriate for shorebirds, but rather identified 3 ecological parameters of productive foraging habitat. These are water depth, vegetation or the lack thereof, and the presence of macroinvertebrates. Each of these components forms a continuum, and each species occupies a range along that continuum. Sometimes that range is narrow, sometimes it is broad. Most shorebirds forage with feet planted firmly on the earth, so they occur in water depths less than 7 inches. A few, like phalaropes, are exceptions. Shorebirds are opportunistic and will forage in many depths if food is present, but they tend to show a preference for certain water depths, which is dependent upon the length of their legs, their bill shape and the length of the bill, and also their foraging methodology. The second parameter is vegetation. Processes moving water and salt in Great Salt Lake wetlands drive dynamic responses from the vegetation. The dark blue on this map shows Great Salt Lake at near low elevation, and the light blue show how the lake inundates in existing wetlands as it did in 1987. Resetting the biologic clock, a repeating process for millennia. Great Salt Lake water inundates the adjacent wetlands. Rooted vegetation is destroyed. Waters retreat, leaving vast expanses of salt flat. Vegetation changes are driven by introduction into the system of fresh water dependent on timing, duration, and depth, and the resulting movement of salts within the system. Each shorebird has a preferred vegetation niche. Snipes occur hidden in dense saltgrass. Species like yellowlegs, stilts, and least sandpipers often forage amid scattered vegetation, while species like marble godwits and dowitchers prefer open water. Shorebirds forage mainly on macroinvertebrates. Absence of available food base on mudflats translates to no foraging shorebirds. Specific macroinvertebrate species are dependent upon salinity. Mudflat versus playa. What characteristics define a mudflat or a playa has long been mired in confusion. The confusion has led to an obscuring effect on the important and distinct role playas play as shorebird habitat on Great Salt Lake, especially in spring migration and early summer. The literature was reviewed and input solicited from soil scientists, hydrologists, land managers, academics, geologists, ecologists, researchers, and biologists. The author's conclusions from a wide and thorough discussion is: mudflat consists of a mixture of water and fine-grained soil, usually clay and silt, occasionally mixed with sand. One of the most important and unique landscape features providing foraging and nesting sites for many species of shorebirds, mainly in spring and early summer, are myriad low-lying depressions scattered near the fringes of Great Salt Lake. These are dry much of the year, but when inundated, often receive considerable shorebird use. They draw down through evaporation to dryness in the summer. From an aerial view, plaias stand out on the landscape as mostly unvegetated, variable shaped white features. Species accounts were written after reviewing literature, extensive surveys and monitoring plans, and the author's decades of personal observation. It is our hope that the information included in this chapter will dispel misinformation on shorebirds and their habitats, fill informational gaps, that a greater understanding and appreciation will lead to a better conservation ethic for the millions of shorebirds dependent on a healthy Great Salt Lake for survival. And I'd like to make a special thanks to Ann and Heidi, John, Brian, and Jamie Butler for their comments. Thank you.